Welcome to today's explainer. Now, if you hear the term green computing and your brain immediately jumps to, some fluffy feel-good elective about saving trees or just remembering to turn off your monitor before you go to sleep, we need to completely reset your expectations. That is a massive misconception. Green IT is not an afterthought. It's a hardcore, globally critical engineering discipline. Today, we're going to tear down those myths and look at the actual mathematics, the frameworks, and the supply chain realities that truly define sustainable technology.
Okay, let's dive right into this because we really need to validate the absolute urgency of this topic right out of the gate. Just look at this metric. Right now, the global IT industry consumes more electricity than the entire country of Japan. We're talking about a gargantuan amount of power required just to keep the lights blinking on our servers, our routers, and all of our devices.
And honestly, it's only accelerating. To put our modern computational demands into perspective for you, training just one massive AI model can emit as much carbon as 5 cars over their entire lifetimes. 5 cars! This means our relentless hunger for data processing is literally throttling the global power grid. This isn't just some abstract environmental issue. This is a very real billion-dollar bottleneck for tech giants who are scrambling to find enough energy just to power their next-generation data centers. So here's our roadmap for this explainer. We're breaking this down into 4 parts. First, the true cost of computing. Second, the triple bottom line. Third, the IT hardware lifecycle. And fourth, the future of sustainable IT. All right, section 1, the true cost of computing. Because before we can optimize the system, engineers actually have to mathematically quantify the damage. When most people talk about a device's carbon footprint, they usually get it, well, about half wrong. They fall into this trap of only thinking about the electricity coming out of the wall. What's really interesting here is that we actually have to split this into two totally distinct engineering metrics: operational carbon, which is what comes from actually running the equipment, and embodied carbon, which is all the emissions generated before you even push the power button. Let's look at operational carbon first. This is the greenhouse gas emission associated with the active running of your IT equipment, powering the CPUs, spinning the hard drives, and crucially, running those massive HVAC cooling systems. The critical thing to understand here is that operational carbon is entirely dependent on your local energy grid. If you build a data center in Ohio that runs on coal-powered electricity, its operational footprint is going to be massive. But if you build that exact same data center in Iceland running on geothermal energy, its operational carbon footprint is near zero. But then we have the hidden giant: embodied carbon. These are the staggering costs incurred before the device even reaches you. We're talking about mining finite resources out of the ground, things like silicon, copper, rare earth metals. We're talking about the extreme energy required for semiconductor fabrication. Factories like TSMC in Taiwan consume massive, massive amounts of power just to maintain clean rooms and run extreme ultraviolet lithography machines. Throw in the global transport emissions from container ships, and the footprint is already huge before you've even unboxed the thing. And this brilliantly illustrates the reality for consumer electronics like smartphones and laptops. Get this, up to 80% of their total lifetime emissions happen outside of their actual use phase. 80%! The vast majority of the environmental damage is literally done the second it rolls off the assembly line. So what does this all mean for you and me? Well, it gives us a highly actionable everyday takeaway. Because embodied carbon is so overwhelmingly high, the single most impactful green IT decision you can make is simply to keep your laptop for 5 years instead of upgrading every 2. Extending the life of the hardware spreads that massive embodied carbon cost over a much, much longer time frame. Moving right along to section 2, the triple bottom line. Let's look at the corporate framework. Think of this as your ultimate mental model for sustainable IT. Corporate accounting can no longer just stare at the dollar signs. It has to balance these 3 independent dimensions: profit, planet, and people, the 3 Ps. If any single one of these pillars is ignored, the entire system is inherently unsustainable. So let's break them down. Pillar 1 is profit, the economic baseline. Look, we live in a capitalist system. If green IT isn't profitable, corporations simply aren't going to adopt it. But the reality is, sustainability actually drives profit. By utilizing server virtualization, companies can consolidate underutilized hardware and drastically reduce their operational expenditure, or OPEX, literally slashing their monthly electricity bills. Plus, by extending hardware life, they reduce capital expenditure, or CapEx.
At the end of the day, green computing is fundamentally about maximizing computational yield per dollar spent on energy. Pillar 2 is planet, the environmental baseline. This is strict environmental stewardship. It means minimizing the depletion of those finite rare earth metals and actively shifting our data centers over to renewable smart grids. But it also means designing non-toxic hardware components right up front. So when a motherboard finally does reach the end of its life, heavy metals like lead, mercury, and cadmium don't end up leaching into the soil and poisoning our groundwater. And pillar 3 is people, the social baseline. So the crucial point is that this is the pillar most often forgotten, but it is absolutely essential. Where exactly is the cobalt for our lithium-ion batteries being mined? Are those supply chains ethical? Furthermore, dumping e-waste in developing nations exposes local populations to severe neurological diseases from toxic inhalation during informal hardware recycling. Green IT demands that technology improves human well-being globally, not just for the end users sitting comfortably at a desk. When we balance these three perfectly, we reach the holy grail, sustainable IT infrastructure. That exact center point in the Venn diagram, where a technological solution is economically viable, socially ethical, and environmentally restorative, that is the ultimate goal of literally every green computing initiative. Let's move to section 3 and see how this builds into the physical hardware, the IT hardware lifecycle. Consider this your ultimate cheat sheet for tracking a server or a smartphone through its entire existence. Every single piece of hardware goes through these 4 distinct stages: design, manufacture, use, and disposal. Let's look at how green IT principles change the engineering at every single step. Stage 1 is design. Honestly, the absolute greenest hardware is hardware that is designed to never be thrown away. Engineers focus here on what's called design for environment, or DFE. That means prioritizing modularity. If your RAM fails, you absolutely shouldn't have to throw a $1,000 motherboard in the trash. It also means making smart architectural choices up front, like opting for highly energy-efficient, low-power ARM chips over those power-hungry legacy processors for specific cloud workloads. Stage 2 is manufacture. Now remember what we talked about earlier? This is exactly where that massive embodied carbon spike happens. So the focus here is rigorously auditing green supply chains. Are the manufacturing plants utilizing zero-water cooling processes? Are they restricting hazardous substances like hexavalent chromium and brominated flame retardants? Right now, there's actually a massive global trend of corporations requiring their suppliers to run fabrication plants on 100% renewable energy just to even pass compliance audits. Stage 3 is use. This is the operational phase, which naturally spans the bulk of the hardware's active life. Everything here is all about power management and resource optimization. Engineers deploy software like dynamic voltage and frequency scaling, or DVFS for short, to intelligently throttle power based on demand. We utilize intelligent sleep states for routers and optimize the physical cooling topologies in data centers. The overarching goal is simple: ensure every single watt pulled from the grid is converted into useful computational work. Finally, stage 4 is disposal. The absolute worst-case scenario here is a landfill. We want to avoid that at all costs. Instead, green IT strives for a circular economy. Hardware must be safely audited and data wiped, then refurbished for secondary markets, if at all possible. If it's not, it goes to certified e-waste facilities following global directives like ROHS and WEE. There, precious metals like gold, palladium, and copper are chemically extracted and injected right back into stage 1 to build brand new devices. It's a closed loop. And that brings us to section 4, the future of sustainable IT. Let's tie this all together. So, we've covered the macro architecture, the footprints, the frameworks, and the life cycles. But mastering the theory is really only half the battle. Now you've got to ask yourself, how mathematically efficient is your data center really? Are you ready to actually calculate real-world metrics like power usage effectiveness and data center infrastructure efficiency? Until then, take a look at your own devices and ask yourself, where are they currently sitting in their life cycle? Keep learning, keep optimizing, and I'll see you in the next explainer.